All right, hello, students of Mary Baldwin College. Dr. Tausman coming to you live once again from my house here in Roanoke, Virginia. In this first presentation, we're going to be going over motoric behavior. And what I'd like you to do is take the first page that has the outline on it, or the agenda on it, and I'd like to really have you type up kind of a detailed story, a detailed outline. You can have little paragraphs in there if you like. And the idea is you'll type that up. You'll have time to send me drafts to hopefully get all the details in, and hopefully the acoustic information I share with you here today will allow you to do this. So the first issue that I wanted to bring up was the idea of motoric behavior. It's kind of interesting. As I'm chatting with you, I stood up from my chair. I'm waving my hands. I'm speaking with all sorts of strong verbal cues here and waving my hands and standing on one foot at this point. Take a look at the picture that I put of me as far as the big picture. Isn't that mildly amusing? The reason I put that picture there was to actually illustrate the example that motoric behavior for humans is very easy in most situations. Look what I'm doing there. I'm holding a weight, standing on one hand, waving. Have I ever done that particular behavior before? No. What allows me to do this kind of behavior just so spontaneously? Well, the idea is I have behavioral plasticity. You can do all sorts of different behaviors, which is called behavioral plasticity, so quickly, simply, and easily. And the question we can ask here is, why is that so much the case? We can look at a baby learning to walk. Boy, that's a great process to watch, from going to crawling to sitting up to moving to walking. You look at a speed skater, and actually I have a little abstract there. Speed skaters, as they learn to skate so well, they get very good at it. What allows that to occur? And then even in, what did I put there, disease states, we see a lot of these movement behaviors change. So there must be something that really allows for this. And we actually know what the answer is. The answer is your brain. Your brain has a lot of different areas that are solely concerned with motoric function. And what we're going to talk about in this unit are some of those key areas that are going on. And actually, if you look at the neuroanatomy in figure 8.1, there are a lot of key structures there. Let me open my textbook to 8.1 here, if I can find it or not. Hopefully I can. 8.1, boy, there's so many different areas of the brain. The cerebellum, and we're going to talk about a few key ones right here. The cerebellum is kind of the one structure in your brain that has more neurons than any other structure in your brain. If you're not familiar with the cerebellum, college students sometimes like to go out drinking on weekends, and then they have trouble walking. That is because the alcohol that is in those products goes up to the brain, goes up to GABA receptors up in the brain, and causes problems with balance and movement. So the cerebellum is very much involved in the equation. Let's see. The substantia nigra is another structure. The substantia nigra has almost all the brain's dopamine in it. And when we talk about Parkinson's disease, this is the structure that is affected. We also have the motor cortex. The motor cortex, and actually I think there's a picture of that as well later on in that particular chapter. Let's see, 8.13, somewhere in there. See if I can find it. Yeah, it looks like on 281. The motor cortex is right at the back of the frontal lobe is the motor cortex, and right behind it is the parietal lobe. All areas of touch are represented in the parietal lobe, and sensation, and all areas of movement are there in the frontal lobe. And so in the frontal lobe, basically that controls a lot of motoric function as well. The other key area that you have is an area right at your muscle level. The last neuron coming out, the motor neuron, innervates the muscle. And I think I have a picture of that as well here. It's called the neuromuscular junction. There's a whole lot of acetylcholine here. So these are some of the key structures that are involved when you actually have motoric behavior occurring. And so the reason we're so good at all these things, we have so much neuroanatomical space for all these functions that it makes the behavioral plasticity for most adults very, very easy to work with. So that'll conclude the first presentation. Thank you.